Alright, we're going to start off with some review. The first thing that we're going to talk about is the circumference of a circle. We've talked about this before. Circumference is equal to pi times the diameter, or circumference is equal to 2 times pi times the radius. Now, if you don't remember, the radius goes through the center of the circle, or from the center of the circle to an edge, so that would be our radius. The diameter goes from one side of the circle to the opposite side, but through the center. Okay, so this would be our diameter. Okay, so let's look at some examples. I want the circumference of a circle with a radius of 9 centimeters. So for this, the circumference, I'm going to use 2 times pi times the radius since they gave me the radius. Okay, so this is going to be 2 times 9. I'm going to move the pi towards the end. Okay, and 2 times 9 is 18 pi. Now, unless I tell you to round to the nearest decimal or to some decimal value, I want exact answers, which means I'm going to leave it in terms of pi. So in this one, for example 1a, the answer is 18 pi. Now, for example b, it says radius of a circle. So they want us to find the radius of a circle with a circumference of 26 meters. Okay, so since they're giving me the circumference, I'm going to put the 26 on the left-hand side, and I want 2 times pi times the radius. So here what we do is I'm going to divide by the 2 pi on both sides. Now I can divide by pi because it's a number. This is going to cancel, and so my radius is going to equal 26 divided by 2 pi, which is going to be about 4.14. Okay. And next we're going to go introduce something new that's called an arc length. And an arc length is a portion of the circumference of a circle. You can use the measure of the arc in degrees to find its length. Alright, so now I'm going to show you what I mean. The arc length in a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360 degrees. So basically what we're doing is I'm taking the circle, and let's go ahead and draw some stuff here. I'm going to call this circle P. And what we're going to do is I'm going to designate a section or a piece of this circumference, the distance around the circle. And I'm going to go ahead and call those 2 points A, and we'll call this point B. Alright, so when I connect them, okay, both of these are radii. And so I'm going to take this section from A to B, and this is what I want, or this is the piece that I want. Okay, and so the proportion comes from this degree right here, this arc in degrees, okay, compared to the whole circle, so which is 360. Okay, so I take the angle over 360, and I compare that to the length of the arc, compared to the whole circle, which is 2 times pi times r. Alright, so now let me show you what I mean. This radius right here is 8. So if I wanted the total circumference, I would do 2 times pi times the radius, which in this case is going to be 8. But since I only want this piece of it, the arc AB, what I'm going to do is I'm going to take this circumference, which would be 16 pi, right? And I want to multiply that by 60 over 360, because this represents, the 60 over 360 represents the piece of the whole circle that I want. So it's going to be 60 over 360 times 16 pi. Okay, if I simplify that out, that is going to become 8 pi over 3. Alright, so now for this next one, I want the circumference, because they gave me here, they gave me the length of xy. So the 4.19 is part of the circumference, which is going to equal or be proportionate to the angle here, the 40 over 360. Okay, so if I cross multiply, okay, going this way to this way, I get 1508.4 is equal to 40c. And if I divide by 40, that's going to give me the circumference. So my circumference ends up being 37.71. We're dealing with inches, so that would be inches. Alright, on this one, they gave me the arc length, but they want the angle measure in degrees. So I know that 44 over my entire circumference, which is going to be 2 times pi times r. In this case, I know my radius, so it's going to be 2 pi times 15.28. Okay, that's going to be proportionate to the angle. So in this case, I'm looking at the angle of RS over 360 degrees. Okay, so if I cross multiply and kind of simplify this out, 44 times 360 is going to give me 15,840. And if I multiply here, the 2 times the 15.28, I get 30.56 pi is equal times the measure of the arc, RS. And if I divide by the 30.56 pi on both sides, I get that this angle, or this arc, is going to be about 165 degrees. And now for example 3, we're going to look at a real-world application of this. We have a tire, the dimension of the car tire is shown. To the nearest foot, how far does the tire travel when it makes 15 revolutions? So in other words, when it goes 15 times around, how far has it traveled? So in order to do this, since they gave me these different dimensions here, and if I were to go straight through, that would be the diameter of the tire. So my diameter is going to equal 5.5 plus 15 plus 5.5, which is going to be 26 inches. Okay, so my circumference then is going to be the diameter times pi. Okay, now I want to find how far it's going to travel 15 times. So this would represent 1 revolution if I went all the way around the circle. So it's going to be 26 pi times the 15 revolutions. Okay, and that's going to give me my distance. Okay, now this is going to be 26 times 15 is going to give me 390 pi. If I'm rounding that, that's going to be about 1,225.2 inches. All right, in this next example, I'm looking at a kind of a track. The curves at the ends of the track shown are 180-degree circles, or arcs, which are semicircles. So basically, I'm cutting this in half right here, and this would be half a circle. Over here would be the other half of the circle. Okay, the radius of the arc of the runner is 36.8 meters. About how far does this runner travel to go once around the track? So basically, I'm looking at this length going this way. Right, if I were to put these two halves together, I would get a full circle, so I'm going to use circumference. But then I also have these two straight sections here that I would have to figure into this problem. All right, and so we're using the red path, which is the 36.8. That's going to be my radius. So the circumference is going to be 2 times pi times my radius, which is 36.8. Since I'm dealing with two halves, I'm just going to figure in the whole circle, and we want to round to the nearest tenth of a meter. So the 2 times pi times the 36.8, if I put that in the calculator, is going to be about 231.221 approximately. Okay. Then I have to figure in, I'm going to take this and I want to add the lengths here. So if this is 84.39, I have an 84.39 on top. So this is going to be 231.221 plus 2 times 84.39. Since I have, again, I have both of these two straightaways. So using that, that is going to come about, or going to be about 400 meters. Okay, now we're going to talk about what is called a radian. Now, a radian is based off of a kind of what's called a unit circle, or just with the simplest whole number that we can think of for the radius. So a radius, the most simplest whole number that we can use, or integer that we could use, would be to have a radius of 1 unit. So then the circumference of this unit circle would be 2 times pi times my radius of 1, which would just be 2 pi. Okay, and since all circles are similar, we're going to use this kind of our base circle of this circumference of 2 pi and compare that to any circle. Alright, so let me show you how to do this. So if I have a degree here, 45, I'm going to take that degree measure and I want to multiply by pi radians over 180. So basically what I do is I take the 45 times pi. I could do it 2 pi over 360, but the 2 and the 360 would reduce to pi over 180. So I would just do 45 degrees times pi over 180, which would come out to be pi over 4. Okay, and we would, if you want to associate or put radians as the unit, because that's what it is. Now, if I want to go the other direction and I want to take the radians to degrees, I'm going to multiply by kind of the reciprocal. So instead of having pi over 180, I'm going to multiply by the reciprocal of 180 over pi. So I take 3 pi over 2, and I want to multiply that by 180 over pi. Okay. Notice that my pi's here are going to cancel. So I'd have 3 times 180 divided by 2. So that would be 270 degrees.